Hello students, this is the exit slip from lesson 2. The unit is the 6th unit on sequences. Lesson 2 was on arithmetic sequences and recursive formulas for those types of sequences. A recursive formula uses a sub n minus 1 or a sub n plus 1. Those are known as the previous term. A sub 1 is known as the previous term. I'll write that in here. And a sub n plus 1 is the next term. And we can call a sub n the current term. So it's giving you a sequence, and you know it's arithmetic because from each term to the next, you're changing by the same amount. It has a so-called common difference. From 4 to 7 is plus 3, from 7 to 10 is plus 3, etc. So your common difference then must be plus 3. So we can say the common, capitalized, common difference is 3, a positive 3. So now we've described the sequence by its common difference. We can also describe its starting value. It's a sub 1, so to speak. My computer doesn't do subscripts like that, or maybe it does. Let's see if I can make it do that. Well, looks like I figured out how to make it do that. So our a sub 1, our starting value, is equal to 4. That's the first value in the sequence. So now we've described the sequence using the common difference and the starting value. We can start using the recursive formula. We can tell that for any term in this sequence, we can take the previous term, add 3 to it, and get that term. So in order to write that out, we start with a sub n, and a sub n is that any term, right? The next thing we should do is say if we want to get that term, we're going to take the term before it, which is a sub n minus 1. That term before it, we have to add 3 to it. So we take the term before it, we add 3, we get the current term. But that's not the only thing you need in a recursive formula. You not only need the pattern, you also need the starting value. So we know that our starting value is a sub 1, and that should be equal to 4. So that is our recursive formula using a sub n minus 1. The next thing we were asked to do is write the recursive formula using a sub n plus 1, which is the next term. So when we talk about recursive formulas, we can say, starting from any term, if you add 3 to it, you get the next term. So the way I'm going to write that out is, starting from any old term, which is a sub n, we can add 3 to that particular term, and then we'll get the next term in the sequence. So in order to write that out, we say the next term in the sequence is a sub n plus 1. And notice that these are subscripts. I know that some students wrote them as numbers that were like the same size as all the other numbers, but you have to write them as subscripts because I'm not actually adding 1 to anything. I'm just indicating that it's the next term in the sequence. Just like the last time, we have to indicate where we start from because this part is only the pattern. So now we say the starting term is a sub 1. Is equal to 4. So notice that they're very similar. They're showing the pattern in the same way with this plus 3, the common difference. They're showing the first term, which is a sub 1. The only difference is for the a sub n minus 1, we're saying any term is equal to the term before it plus 3. And for the n plus 1 term, we're saying any term plus 3 gives us the next term in the sequence. Very, very similar. For this next problem, it gives us a recursive formula. It's using this a sub n minus 1 notation, which means the previous term. So using the recursive formula, whatever the previous term is, we add 9 to it, and we get the current term, and it tells us that a sub 1 is equal to negative 15. Write the first 5 terms of the sequence. Okay, well, the first term of the sequence is going to be exceedingly simple because it tells us it's negative 15. Now let's think through this. The previous term of the sequence plus 9 is equal to the current term. So the previous term in the sequence, we can consider it to be negative 15. If we add 9 to that, we're going to get the current term of the sequence, the term that's before the previous, that's after the previous term. Kind of confusing. But suffice it to say that all we have to do to negative 15 is add 9 to it, and we get negative 6. The next term in the sequence is taking that term and adding 9 to it. So that would be 3. Next is 12, and next is, of course, 21. Finish those curly brackets because that's required. That's part of the notation. And if you think about it, you can rewrite this recursive formula using a sub n plus 1 notation. This is a little bonus for you. If I wanted to rewrite this formula, I could say take any term, let's say an, and if I want to get the next term, I have to add 9 to it, and that would give us not the an term, but the next term of the sequence, which is a sub n plus 1. And then we have to finish it off by saying the first term of the sequence, a sub 1, is negative 15. So there you have it. Those are the 2 answers to the exit slip from lesson 2.